All right, guys, my name's Justin Hughes. I'm a firefighter with the City of Paris. I work with Jamie. I'm also a volunteer at Puryear. I've been there since 1998, I believe. Tonight, I'm going to try to teach y'all a little bit about fire hydrants. I don't know if anybody's worked with fire hydrants, been around, or done much with them, but we're going to learn a little bit about that tonight. Fire hydrants are basically to provide water for firefighting purposes. They're installed on both public and private water systems. They consist of an upright steel casing attached to the underground distribution system. There's two types of fire hydrants. This right here, this is a wet barrel hydrant, which means there's always water in it, and each outlet is individually controlled. Most of the time around in this area, you're not going to see a wet barrel hydrant. Those are mainly for your deep southern states, southern Florida. I've been to Orlando. I've seen several wet barrel hydrants there. Dry barrel hydrants. This is primarily what is going to be in our area. It says they're used in cold climates. The hydrant valve is located at the base, and water flows into the hydrant only when it is needed. Draining a dry barrel hydrant. After each use, water drains out through an opening at the bottom of the barrel. When the valve is open, the drain hole is closed. When the valve is closed, the drain hole is open. Hydrants may not drain if they are clogged. Always make sure whenever you're opening a hydrant to open it all the way. If you partially open a hydrant, you may get water to start coming up beside the barrel itself, which it is coming out that drain hole, and you will get soaking wet. Fire hydrant locations. They're located according to local standards and nationally recommended practices. Kind of recommend every 500 foot in a residential area. Around here, most of the times they're within about 1,000 foot of each other. And in big cities, they recommend at least every 300 foot, like Nashville. Every corner, you're going to see a fire hydrant because of all the high rises. Hydrant operation. You need to be proficient in operating a fire hydrant. You don't want to try to turn one on too fast or turn one, shutting it off real fast. That's not good on the system. Of course, each department may have their own variances on that procedure, and always follow your SOGs or SOPs. Whenever you're getting ready to operate a hydrant, always check for visibility if you can find it. Make sure that it's not buried under briars or there's bushes growed up against it, which we run into in Paris quite often. There's somebody plants a bush right in front of the hydrant, and you know it's there, and then you can't find it. And before you operate, always make sure there's no damage, that the caps are not missing the nuts, there's no cuts or dings in the barrel itself. And when you take your caps off, always inspect inside the barrel and make sure there's no debris of any kind, like a mouse has gotten grass or anything like that, because if you open that hydrant up without checking it, that flows into your pumper, and then you've got a whole other mess on your hands. And always make sure your caps are in good working order, that they're easy to get on and easy to put back off. Open it up and check, make sure you have good water flow. Shut it down, make sure that everything drains out, and then you replace the cap. This is testing the hydrants. This fire suppression companies are often assigned to test the flow from hydrants. They're simple, but a simple understanding of hydraulics and attention to detail is required. That is true. There's a lot that goes into your calculations on testing your hydrants. You basically have three types of pressure: your flow pressure, your static, and residual. Loss. Water hammer. This is very important. Whenever you're opening up a hydrant, if you open it up too fast, that puts a lot of stress on the water distribution system, and you will feel the ground shake from the water surging. And if you shut your hydrant down too fast, you'll feel it surge again. And when that happens, there's a pretty good chance you're going to blow a main line out. Luckily, I haven't seen that happen, but I've seen videos of the aftermath of firefighters doing that. So make sure you always open and close your valves slowly. Back up there on. As far as fire hydrants, another thing that I didn't see that was covered right here is your color codes. With your color codes, your colors are going to be red, orange, green, or blue. Red is kind of your worst color. That means you're flowing anywhere from 0 to 499 gallons per minute out of that hydrant. Orange, you're from 500 to 999. Green, 1,000 to 1,499, and then blue is 1,500 and above. I always remember this: red is bad, orange is okay, green is good, and blue is best. So if you see a blue type hydrant, you know you've got plenty of water. Now there are other areas in other cities that have different color schemes. Like in Puryear, our hydrants, all our bonnets are painted yellow with the exception of about 4. That yellow bonnet indicates that that is on a 6-inch water main. We've got 4 hydrants up around Harrelson School that have an orange bonnet, an orange bonnet. That indicates it's on an 8-inch water main. But if you'll notice, our caps vary in color depending on the flow pressure out of the hydrant. Let's see here. Another thing to remember too, if you come across a red hydrant, if it has a red bonnet and red caps, of course that means that you're in that 0 to 499 mark. The Department of Environment and Conservation says that you cannot hook your pumper to that hydrant for the purpose of fighting fire. It does not produce enough water to fight fire with, but you can fill your tank from that. So you'll find there's several areas that there are just solid red hydrants. But in aspect of Puryear also, we have 3 hydrants that are red, but they have orange caps on them, which they're producing almost 750 gallons a minute. There's water there, and it's kind of one of them, you can use it, but you need to be leery that you could drop pressure at any time and not have the water you need to fight the fire with. And as far as your testing of your hydrants, ISO recommends that you flow test your hydrants every 5 years. NFPA also recommends that. The American Water Works Association recommends every 10 years. I say 5 years is good. I wouldn't stretch it out to 10 because you could have a lot of variance in that amount of time. After we get done with some of this PowerPoint presentation, I'll have you guys go outside and we'll go over the operation of slowly opening and slowly closing a fire hydrant. Another thing I'd recommend, get out in your area and familiarize yourself where your fire hydrants are at. Learn how close they are to the road, if they're a pretty good distance off, if it's going to take a lot of hose to stretch to it. I've seen some that are probably about 300 foot off the road. Let's go over some hose here. You have supply hose, which is used to deliver your water. It's designed to carry large volumes of water at lower pressures. And then you have a tack hose, which is used to discharge water and operates at higher pressure, which is probably going to be your pre-connects on your pumpers. Of course, your hose ranges in size from 1 to 2 inch, which would be small diameter hose. And then your medium diameters are 2.5 to 3.5 inch. And then large is 3.5 and larger, which most typical around this area probably be 5-inch hose. Your tack hose. It needs to be tested annually, and that says tested to 300 PSI. If any of y'all go on to attend the pump operations class, you're going to learn that, especially if you're using your pumper to test hose with, you only pressure test your pumper to 250 PSI. So you won't be able to exceed that to test your hose. So 250, unless you have a hose tester, will be the only way you're going to get to test at 300. And then your supply hose, your large diameter hose, is tested to 200 PSI, and that is annually also. Hose is constructed, it has an inner waterproof liner and 1 or 2 outer layers. Can be double jacketed or rubber jacketed hose. Your inner waterproof liner, of course, it prevents leakage and smooth surface to reduce the friction. And it's attached to your outer covering. There's your example there. Your hose couplings. It's used to connect individual lengths of hose, connect hose to hydrants, valves, nozzles, fittings, and appliances. You have two types of couplings. You have threaded couplings, which is used on hose up to 3" and consists of a male and female, and it is a standardized thread. Back in the old days, a lot of fire departments, everybody had their own thread. And then when you had one department went to help another department, nobody's hose hooked up, so they came up with the standard thread. And if there's any leakage with a thread, you can take your spanners and tighten that. And then what you have, the stores couplings on your large diameter. The good thing about this is there is no male or female, so you can lay that hose out from any direction and make a connection with it. But you do have to have an adapter to go from the stores to threaded couplings. Uncoupling your hose. Never uncouple a charged line. That's not going to be good. Always make sure you shut off the water supply and bleed the pressure off before you uncouple it. We had that happen at the pump operations at the fire school. We had a layout to the ladder truck. Well, they'd shut everything down and they'd put a hose clamp in between the ladder truck and the pumper. Well, nobody thought about all that pressure backfeeding down off that ladder pipe until one of the guys went over there to uncouple it. He got soaked, and it wasn't very fun. A tack hose is used for fire suppression, carries water from the pumper to the fire. Commonly 1.5" or 1 3/4". 1 3/4 is starting to replace 1.5" slowly. I don't know right around here in Henry County, but in a lot of places they're going to 1 3/4. Of course, you have your 1" booster lines and then your 1" forestry lines. Your supply hose is used to deliver water from the engine to the engine from a pressurized source. It ranges from 2 to 6" diameter. Your large diameters are much more efficient for moving the bigger water because you have a whole lot less friction loss with it. Your supply hose, soft suction hose, it's usually a short section of large diameter. It's connected from the engine directly to the steamer outlet on a fire hydrant, just like right there. Hard suction hose used to draft water from a static source. Water is drawn into the pump on an engine or into a portable pump. Causes of hose damage. You have mechanical, hot and cold, chemicals, and mildew. Hose appliances, wise. It splits one hose stream into two. Gated wise equipped so that the flow of each water splits lines can be controlled independently. You see this a lot. A lot of departments, they have what they call a city lay on the back of their truck, which will be your 2.5" line with that wire right there, and then you have 2 1.5" coming off. And a lot of times that's used in a reverse lay situation, which we'll discuss later. And you have right here a hose appliance, which is a water thief. It's similar to a gated Y. It has an additional 2.5" outlet on it. A Siamese connection combines the 2 hose lines into one, often used on engine outlets, master streams, and fire department connections, or standpipes. Now, adapters. Adapters used connect same sizes of hose, but different threads. Like you'll get one company may lay out a forward lay, and the other one may come in with a reverse lay, and you've got double males and double females together, so this makes it easy to connect those. And reducers used to attach smaller hoses to larger. Commonly used 2.5" to 1.5". That's going to be your most common reducer. Hose jacket. Used to stop a leaking section of hose. It consists of a split metal cylinder that fits tightly over the hose. Used to, they had, and I haven't seen this in a long time, but a leather hose jacket, burst hose jacket, which you had to manually put around the hose and strap it together just like you was putting a belt on. You got really soaking wet doing that. That right there, you can take that appliance, pick your hose up, scoot it under with one foot, come around to the side and take your other foot and close it. And you're not bent over trying to strap something together to get the water to stop. Hose roller, it's used to protect the line being hoisted over an edge. Like if you was on a 3rd-story building and you were hoisting a line up, this would be good to sit on the edge of that so it didn't scuff on the brick or concrete. Hose clamp is used to stop the flow of water that can be used if a hose ruptured or has to be connected to a different appliance. That's about the only times you're going to use that. Valves. They control the flow of water in a hose or pipe. Different types are ball, gate, and butterfly. And when we go outside here in a little while, we'll go over the different types of valves. Hose rolls. The easiest way to transport a section of fire hose. It can be rolled in many different ways. You have a straight roll, the single donut, the twin donut, or the self-locking twin donut roll. Fire hose evolutions. Standard methods of working with fire hoses to accomplish different objectives. Each firefighter should know how to perform all of the standard evolutions, divided into supply operations and attack operations. The objective is to deliver water from a source to an attack engine. Be done with the forward lay, which starts at your hydrant, proceeds to the fire, or the reverse lay, which starts at the fire, then proceeds towards the hydrant. Forward hose lay allows the first engine to establish a water supply without assistance, places the attack engine close to the fire, and can be used with medium or large diameter hose. This is going to be probably your most common lay that you'll end up doing is a forward lay. A four-way hydrant valve. That's used when a supply engine may be needed at the hydrant. When the four-way is placed at the hydrant, water initially flows. The second engine can then hook to the four-way and boost the pressure to the supply hose. A lot of times when big cities, when they have a major fire in a commercial structure, they'll have to do this to boost the pressure because they're putting such a drain on the system. Reverse hose lay. The hose is laid from the fire to the hydrant, used when the attack engines begin to attack without a supply line. The later arriving company stops at the attack engine and lays a line to the hydrant. There's a lot of good videos on YouTube. Detroit Fire Department uses the reverse lay a lot. I've noticed watching a lot of their videos. Split hose lay. Performed by two engines, used when hose must be laid from two different directions and requires coordination by a two-way radio. Loading hose can be loaded in different ways. Hose must be easily removable from the hose bed. Many hose beds are several feet above ground, which makes it very difficult a lot of times. This load, the flat hose load, is the easiest. Can be used for any size. The hose should lay flat without any twist or kinks in it. The horseshoe load. The hose stands on the edge, place it around the hose in a U shape. Contains fewer sharp bends than other loads. Can be used for large diameter, but it causes more wear on the hose. The accordion lay, which is one I'm most familiar with other than the horseshoe. It's laid side to side in the bed, easy to load, but it creates sharp bends and more wear, and is not recommended for your large diameter. All right. Well, guys, we're going to take a quick break here. We'll go outside and we'll go over some things out in the apparatus bay, the valves, different kinds of appliances, and things like that, and then we'll come back in here. Any questions on anything? Anything any kind of unfamiliar with, want to go in a little bit more depth on? Or no? All right. We'll go outside in the apparatus bay and look at some stuff.